Hello, everyone. Here we will work on number 41 in the first section of chapter 8, finding the interval of convergence for the following series. Okay. We already knew there are two-step procedures. The first is to apply ratio test for absolute convergence. And from here, we should be able to figure out the center and also the radius of convergence. All right. So we start from evaluate the ratio. So as I said, do not forget to add the absolute value to the ratio, and then do the simplifications. And notice that the final answer still involves the absolute value, in particular for this term, 2x minus 5. All right. Now it turns out that limit will be 1/3 times this term. Okay. By the ratio test for absolute convergence, we needed to make sure this limit was strictly less than 1. Okay. That means we need to solve this inequality problem. However, we can indeed solve as 3 equation problems, right? Make the left-hand side to be 0, and also after we get rid of the absolute value, potentially it could be 1 or -1. All right, solve the equation problems. From these 3 cases, we should be able to figure out the center, which is 5/2, and the 2 and 0.1 and 4. This is almost the interval of convergence. However, we need to do one more step, which is the endpoint check. There are 2 endpoints, 1 and 4. Do the individual check, plug in the numbers, right? And both, one of them is a terminating series. However, we can use the divergence test to figure out it actually diverges. Similarly for the second case. Okay, so after the step 2, we can claim the interval of convergence. All right, it's actually 1 to 4. All right, so just a quick recap of this one. 2-step RTAC to find out the center and the radius of convergence. Step 2, performed endpoint check, all right, to finalize the interval of convergence. Okay,